Hello students, Jai Swaminarayan to all. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Bhat Gandhinagar. I am welcoming all the students who are listening me through this platform, and I am going to present solar resources, radiation and optimization in this presentation. So this is my topic for the presentation, in which you are going to study the resources which are currently we are using for the means as an application of the solar energy, and the radiation level which is available on the earth, and the optimization, or we can say the certain optimization we can do to get the maximum efficiency from the sun. So these are the points that we are going to study in this presentation. Now let us see how the solar resources, radiation and optimization can be done. Now the main things that you are going to learn through this presentation are solar radiation, then the spectrum beam from the sun and the reflected light from the sun. And then after the next point that you will aware with the standard test condition for the solar system, and the sun position and the say collector angle and the optimization that can be done for the maximum output from the solar system. So let us see how it can be done. So before we start this presentation, these are some instruments which are available which operates on the solar energy. So आप इसमें से थोड़े बहुत इंस्ट्रूमेंट ऐसे होंगे कि जिसके बारे में आप अवेयर होंगे, एंड थोड़े बहुत इंस्ट्रूमेंट ऐसे हैं कि जो जिसके बारे में आप नहीं जानते होंगे. सो दिस इज़ से कंसंट्रेटेड सोलर पैनल मीन्स सोलर रेडिएशन डिवाइस. सो यहाँ पे आप देख सकते हो कि उसका शेप कैसा है कि ड्यू टू दिस शेप द सोलर रेडिएशन विल बी कलेक्टेड बाय दिस डिस्क एंड इट विल बी रिफ्लेक्टेड ऑन द सेंटर पोर्शन. दिस इज़ द रॉड. एक यहाँ पे रॉड है, उसके बीच में हमने कुछ यहाँ पे जिस चीज़ को हमको गर्म करना है उसको हमने यहाँ पे उसको हैंग किया है. एंड द कलेक्टेड एनर्जी फ्रॉम द सन विल बी रिफ्लेक्टेड थ्रू दिस डिस्क, और उसको एक ही पॉइंट पे वो एमिट करती है, और एमिट करने से वो जो चीज़ है यहाँ पे जो भी हमने गर्म करने के लिए रखी है वो तुरंत गर्म हो जाती है. नाउ दिस इज़ सोलर कुकर. जनरली वी आर यूजिंग और सम ऑफ द पीपल आर यूजिंग इन आवर कंट्री फॉर द कुकिंग. तो सोलर कुकर में भी सेम प्रिंसिपल है. ये जो ग्लास है उसके ऊपर से सन का रिफ्लेक्शन आता है और यहाँ पे एक ब्लैक फिल्म होती है, और उससे रिफ्लेक्ट होके अंदर सोलर एनर्जी मतलब सोलर रेडिएशन या फिर सन की लाइट जाती है, और उसकी वजह से द फूड विच वी हैव प्लेस इनसाइड दिस कुकर वो मतलब धीरे धीरे कुक हो जाता है. और ये तीसरा है, आपने देखा ही होगा, ये सोलर वाटर हीटर है. यहाँ पे मीन्स द सनलाइट विल बी कलेक्टेड बाय दिस पाइप. इसके ऊपर हमने रखा हुआ होता है सोलर फिल्म्स. एंड यहाँ पे कैसा होता है कि ये जो पाइप है उसके अंदर वाटर का सर्कुलेशन होता है, एंड ड्यू टू द कलेक्शन ऑफ द से सोलर मीन्स सनलाइट, तो ये पाइप है वो गर्म हो जाती है, एंड द सर्कुलेटेड वाटर जो यहाँ से पास हो रहा है वो जो हीट होती है उसको ग्रैब कर देता है, और वो पानी जो है वो गर्म हो जाता है. तो उसको हम अपने घर के लिए या फिर मतलब कुछ भी काम के लिए उसको हम गर्म पानी को हम यूज़ कर सकते हैं. नाउ ये सोलर पंप है. बेसिकली ये इरिगेशन टेक्नोलॉजी में अभी यूज़ होता है. तो बहुत सारी जगह ऐसी है जहाँ पे लाइट का बहुत प्रॉब्लम है. तो मीन्स स्कारसिटी, ड्यू टू द स्कारसिटी ऑफ द इलेक्ट्रिसिटी, वी कैन से हम ये सोलर पैनल वहाँ पे लगा के ये पंप को हम चला सकते हैं, और खेती के लिए या फिर एग्रीकल्चर के लिए हम पानी का यूज़ कर सकते हैं ये पंप चलाने के लिए. इसके लिए हमारे पास टाइम का कोई मतलब जैसे इलेक्ट्रिसिटी अवेलेबल है या उसके लिए हमको उसका कुछ वेट नहीं करना पड़ता, और इसीलिए ये सिस्टम अभी बहुत ज़्यादा लोग अडॉप्ट कर रहे हैं. और ये इमरजेंसी सोलर लाइट है. जैसे पूरा दिन सनलाइट से चार्ज होती है, एंड देन आफ्टर वी कैन यूज़ द स्टोर्ड एनर्जी फॉर द मीन्स ये जो लैम्प है उसको चालू करने के लिए हम स्टोर एनर्जी का यूज़ कर सकते हैं. एनी अदर डिवाइस इफ़ यू नो देन you can discuss. Now let us see the energy from the sun, or we can say the extraterrestrial. So over here you can see that this is say in, the planets which are in our galaxy. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, and this is the distance which is from the Sun. So it is say 57 into 10 raised to 9 meter. Similarly for other planets, and we are talking here about the Earth, so that's why we will discuss about the Earth only. So over here you can see that this is the center of the say Sun, and this is the radiation intensity from the Sun, so that's why it is indicated as H Sun, means intensity from the Sun. And this is the say radiation intensity which is received for on the particular planet. So yes, whatever the energy generated means on the Sun, or it is just because of the fusion, like fusion of the say atoms. So यहाँ पे आप देख सकते हो कि due to the fusion the energy is reflected on in the say space, or we can say in the universe. So yes, if we talk about Earth over here, यहाँ पे हम Earth की बात करें तो due to the electric say field and the magnetic field, यहाँ पे मतलब एनर्जी रेडिएशन अवेलेबल है, और वो एनर्जी रेडिएशन हम यहाँ पे अर्थ पे रिसीव कर सकते हैं. तो ये जो है वो क्या है कि जो मेन सोलर ई रेडिएशन वाट पर मीटर स्क्वायर अवेलेबल है डिफरेंट प्लैनेट्स पे वो बताया गया है. तो अभी हम अर्थ की बात करें तो अर्थ पे जो सोलर ई रेडिएशन अवेलेबल है वाट पर मीटर स्क्वायर वो है 1366.1. सो मैं यहाँ पे एक बात बोलना चाहूँगा कि अभी थोड़े टाइम पहले इलेक्ट्रिकल के एक फैकल्टी ने आपको सोलर पीवी सिस्टम के बारे में बताया था कि सोलर पीवी सिस्टम में इलेक्ट्रिकल आउटपुट कैसे आता है, और वो पूरा पाथ आपको बताया था. तो बेसिकली जो सोलर पैनल जो होती है वो सोलर ई रेडिएशन पे काम करती है. जितना ई रेडियंस अवेलेबल है ज़्यादा, वहाँ पे सोलर एफिशिएंसी मीन सोलर पीवी पैनल की एफिशिएंसी बढ़ जाती है, और सोलर पीवी पैनल विल प्रोड्यूस द मैक्सिमम आउटपुट. अब यहाँ पे आप देख सकते हो कि ड्यू टू द कोर फ्यूजन ऑफ say hydrogen and helium, the temperature is around, you can see that this 20 not K. So this is the temperature of the Sun due to the means fusion energy, and this will be reflected on certain planets which are available in the galaxy. So you can see that this is the radiation which is received on the Earth, and this is the distance around from the Sun to the Earth is around 150 into 10 raised to 9 meter. नाउ अब हम थोड़ा डिटेल में देखेंगे उसको कि हमारे पास जो एनर्जी आती है अर्थ पे वो किस तरीके से आती है. नाउ हाउ विल वी रिसीव दिस एनर्जी ऑन द अर्थ. सो यू कैन सी दैट दिस इज़ द सन एंड दिस इज़ द अर्थ. देर इज़ नो ऑब्स्टेकल फ्रॉम बिटवीन सन एंड अर्थ, सो इट इज़ कॉल्ड डायरेक्ट एनर्जी. एंड this is just because of the cloud. So you can see that there is a cloud between sun and earth, so we will get the diffused energy at the time of sunset and sunrise. If the clouds are available, then this is called the diffused energy. So you over here you can see that we are inputting 100% over here, and then after the ozone layer will absorb around 2% of the energy, and it is 20 to 40 kilometer away from the sun. And then after the upper dust layer which is on the space, so it will it is around 15 to 25 kilometer from the ozone layer, and it will absorb the 1% of the input means energy. And then after we have the air molecules which are available on the atmosphere of the earth. So it is say 0 to 30 kilometer away from the upper dust layer, so it will absorb around 8% of the energy which is reflected from the sun. And then after we have the water vapor around which are available after say air molecule which is 0 to 3 kilometer away from the air molecules, and it will absorb the 6% of the energy. And then after we will have the lower dust layer, it is 0.0 to 3 kilometer away from the water vapor, and it will absorb the 1% of the energy which is radiated from the sun. So yes, we'll get the direct to earth, it is around 70%, and the scattered, which is means on the earth, which is 7%. So yes, we'll get the global or we can say total solar radiation is equal to direct beam that we received over here, and the diffused or we can say scattered light which we received over here. So it is an addition of these two beams, and you can see that the around 1%, 0.5%, 1% and 0.5% energy of the sun will be scattered to the space, which is say total 3% will be scattered from the earth surface. So this is the absorption of the energy in certain layer of the means layers which are available from sun to earth. So this we will keep in mind while we use the solar panel or solar PV system for the generation of the electrical output. So basically the global or we can say total radiation, that is the addition of the direct beam which we are receiving from the sun to earth, and the diffused or we can say scattered light that we received, so it is an addition of that too. So now the air mass that we are going to calculate over here. So basically air mass is say ratio of y and x, and now what is y and what is x? So over here you can see that this is the surface of the earth, and this is the sun position which is directly means on the head, and this is the angle means the angular position of the sun from this point. So this is x and this is y, and this is called the theta angle between the first position and the second position of the sun. So yes, we can find out air mass using this equation 1 upon cos theta. So yes, air mass which is available say as per the reference, say radiation in the space, so it is 1366 watt per meter square, and these are certain means air masses, and you can see over here. So air mass 1.5 global that we have considered in the previous slide. So normalized AM 1.5 spectrum which gives the 1000 watt per meter square. So that shows that this energy is available in the space. So according to the air mass, the references that we are used over here for the measurement of the power density using this formula. So you can see that at AM0 to AM1, then AM1.5 G, then AM1.5 DIR matlab direct means direct beam component of AM1.5, and then means air mass 1.5 diffused, that air mass 1.5 diffused that we get, and air mass 1.5 G. So this is the say global, and normalized AM 1.5 spectrum to give, that will give the 1000 watt per meter square. So according to this this air mass or power density that we received from the sun, we use our solar PV panel for the standard test condition. So this we are believing that we are getting 1000 watt per meter square on our in our country whenever the sun rises to sunset, and this is the power density that we received from the sun on the solar PV system. So this is the formula for the air mass. Now let us discuss the solar spectrum. So yes, you already aware with this prismatic spectrum of the solar. So these are the color which are indicating that AM 1.5 global is having a red color, and the green is AM 1.5 direct, that direct beam that we received on the earth, or we can say a specific point, and this red one is say AMO, say ASTME. These are the say solar spectrum measurement means standards, and this is the wavelength on the x-axis, and on the y-axis we are having the spectral radiation in say watt per meter square, or we can say nm inverse. So over here you can see that the radiation which is available maximum is around 500 to 600 means nm wavelength. So yes, you can find out the solar constant, that is AMO is equal to 1.36 kilowatt per meter square. So this is the solar constant that we get from the spectrum, and this is the value of the solar constant, that is 1.36 kilowatt per meter square. Now in this you can see that splitting of the solar beam. So in this is the beam which is imparted on this the prism, and these are the color which are say splitting from this prism, and this is the point, or we can say level, which is indicating the value of the solar constant. Now let us discuss the standard test condition for the solar PV module, or we can say solar PV panel. So over here you can see that this is the setup which we are using for the test the condition of the solar PV cell or module, and we are having this standard, that is AM 1.5G normalized at 1000 watt per meter square. So this is the condition for the means checking the to check the efficiency of the solar PV module at the standard rating. So the radiation that we are getting, that is normal, and the temperature that we are keeping at the time of measurement, it is 25 degrees centigrade. So yes, this is the standard state test condition for the solar PV module, and this is the actual practical setup, and this is the diagram which is indicating that we are keeping 25 degrees centigrade temperature for the measurement, or we can say test the solar PV panel, and this is the bulb through which we are is radiating the energy on the solar PV panel. So for that we require this means we need to means keep this parameter for the standard test condition. Means we need to check on say AM 1.5G normalized, and the radiation that we are getting at 1.5G normal, that is 1000 watt per meter square. So we will get the maximum output on this when we set this parameter, at that time we will get the maximum output from the solar PV system. Now yes, for the 1.5 G and 1000 watt per meter square, we are getting the maximum efficiency from the solar PV module. Now these are certain weather sensor which we use to sense the temperature and the other parameter of the means atmosphere. So yes, you can see that the pyranometer which is used for the say global or horizontal irradiance that we are getting from the sun, and this is again a solar sensor which measure the global horizontal irradiation GHI, and this is the pole on which we have mounted this all these devices that will measure the weather condition where we have established, or where we have placed our solar PV system for the generation. So this is the automatic weather station, and this is unsupervised means weather station. Once we use this devices for the measurement, then after it will measure all the weather condition automatically, and it will give the exact weather condition for that particular place. Now this is the shielded temperature sensor which measure the temperature of the surrounded area where we have used our solar panel, and this is the pyroheliometer which is used to measure the direct or normal irradiation DNI, and this is the cup type anemometer. Generally it is used to measure the temperature, and this is the ultrasonic anemometer. So application of the both the anemometers are same. So these are the devices basically which we use to measure the weather condition where we have placed our solar PV system for the electrical output. Now This is the peak sun hours. So basically we all know that the sun rises at around 6:30 or after 6:30 a.m., and then after it will set say after say 6 p.m. So this is the time where we are getting the solar solar irradiation. So the radiation that we get in watt per meter square at the peak time. So over here you can see that we are starting from the 7 a.m. to 6 p.m., and this is the graph that we get the actual irradiation which we received from the solar during this hour or during this period. So this is the say normalized irradiation with the same energy content. So over here we have taken the mean value of this rising time to setting time of the sun. So the for the 5.5 hours in between 7 a.m. to 6 p.m. we are getting the maximum irradiation and will get the maximum output from the solar panel. So yes, we are getting 1 kilowatt per meter square standard irradiation. At that time our solar panel will give the maximum output. So when the peak sun hours is commonly used means term for the say average, or we can say daily insolation in unit of say kilowatt hour per meter square, and for particular 5.5 hours we are getting 5.5 kilowatt hour per meter square per day. So yes, this is we need to keep in mind while we are using the solar PV module, and we are finding the efficiency of the solar PV system. Now this is the insolation map which is available say on the our country India. So yes, you can see that this are the colors which are showing that the maximum irradiation which is available on the particular part of our country. So you can see that the maximum insolation which is available in the Rajasthan and the Leh Ladakh. I would like to add something over here. The solar PV, many of say you are believing that when we have more temperature then solar panel will give the maximum output, but the main parameter that is for the maximum output is temperature. So when the irradiation which is available is around 1000 watt per meter square, and the temperature is say around 25 degrees centigrade, at that time our solar panel will give the maximum output. But in the area you can see that this is the area of the Rajasthan, and this is what the Leh Ladakh, or we can say JNK. You can see that at this point the temperature say go around 45 plus in the summer season, and in this whether it is a summer season, the maximum temperature will be 25 to 27. So at that time you can see that this place as we have the maximum irradiation which is available at this place at this point means आप अगर देखोगे तो दोनों means weather condition में means suppose it is a summer, तो summer में the solar panel which is say established over here will give the maximum efficiency, because यहाँ पे temperature भी maintain है. यहाँ पे एक प्रॉब्लम है, द टेम्परेचर विल गो राइज. सो due to this area or we can say temperature, the efficiency of the solar PV panel will get reduced. So this is say the map which is showing the maximum solar irradiation which is available on our in our country. So as you know that the Tamil Nadu is having say largest solar PV plant, and Rajasthan means the north side of the Gujarat, or we can say Charanka, is having the largest solar plant, and we are planning to establish a largest solar power plant at in the Leh Ladakh also. So yes, we are going to use this irradiation for the say maximum power generation for the country's growth. So this is showing the insolation which is available on our means through this map on our we can say country. So let us see the solar system day and night. So you are aware with the solar system. So in the solar system, sun is at center point. So Yes, just because of the rotation of each and every planet, we are having say day or night on our planet due to the movement of the sun and movement of the earth. You can see over here the shadow portion. This is the night, and this is right side is showing the day on the earth. So this is our say solar system, day and night. Now in this you can see that the sun path. So yes, from the sunrise to sunset it will take this path over a day, and over a year the sun pathway is say different for particular year, or we can say for particular time. This is the means position where we are standing, or suppose हम यहाँ पे खड़े हैं, तो you can see that this is the position of the sun. It will rise in the east side and set into the say west side. So this is the position, means this is the path the sun will take to rise to set. So yes, for a particular day you can see that this is the path that will follow by the sun, and you can see the shadow of the house also according to the motion of the sun. And this is the shadow of the earth, shadow of the house due to the say changing of the sun path throughout the year. So this is showing that the according to this motion we need to say place our solar PV panel so that it will give the maximum output. So yes, you can see that this is the north pole, and then this is the south pole, and this is the equator. And in this, suppose we are standing over here, so this is the say the path which will follow by the sun, and this is where we have standard. So thus the sun will follow this path from east to west, and during a day you can see that the shadow that you have already observed से मीन्स आप जब देखते हो सुबह, तो आपका खुद का जो शेडो होता है वो लंबा होता है, एंड देन आफ्टर इट विल से बिकम नैरो व्हेन द सन इज़ ऑन द टॉप ऑफ आवर हेड, एंड देन आफ्टर जो अगर शाम को आप देखोगे तो अगेन आवर शेडो विल बिकम लार्ज. सो ये पूरा दिन का है, जैसे सन का मोशन होता है, अकॉर्डिंग टू दैट मोशन द shadow will be moved, and this is for the year. Now अगर आप यहाँ पे खड़े हो तो डिफरेंट टाइप के एंगल क्रिएट होते हैं ड्यू टू द सन पोजीशन. सो दिस इज़ द वर्टिकल पोजीशन वेयर वी हैव स्टैंडर्ड, एंड दिस इज़ ईस्ट वेस्ट नॉर्थ एंड साउथ. सो आप यहाँ पे हो सपोज, तो द एंगल फ्रॉम योर हेड टू द पोजीशन ऑफ द सन इज कॉल्ड द जेनिथ एंगल. इट इज़ 90 माइनस अल्फा. And then from the sun to the horizontal line that we have drawn from our say place where we have standard, that is called the altitude. Means the position of the sun from the earth, and that will show the altitude. And the horizontal line that we have drawn, and from that horizontal line to means the line of the sun, that's horizontal line to the south position, you can see that it is called the azimuth angle. So azimuth angle is very much important for the maximum output of the solar panel. So this is the ground plane, and these are the angle that we are measuring for the better output of the solar panel. And from that we can place our solar panel correctly, so that we will get the maximum efficiency of the solar panel. Now this is the combined sun path. You can see that in the June, in the September, in the December, you can see that this is the position of the sun, and that we have discussed in the last previous slide. So in which we have shown that throughout the year the sun path will be different. In June you can see that it is taking around 23 degree north, and then after you can see that in the September it is changing, and in the December it is again changed. So according to this we need to use, or we need to place our solar panel so that it will give the maximum output. So this is the sun path of the Ahmedabad, which is showing that at the longitude 72.40 east and latitude is 23.02. So this is the angle that we are going to use for the placement of the solar panel for the maximum efficiency. Now as this graph is showing the sun path, so for the particular year you can see that the output is for the particular say month. You can see that this is the April, then this is March, February. So this is the say practical waveform that we have drawn, and that will show that the output, or we can say sun path of the Ahmedabad according to the longitude 72.40 east and latitude 23.2 degree. And from this say sun path diagram, we can say that this particular month or this particular time we will get the maximum output or efficiency from the sun or solar PV module. Now this is the sun path diagram, say polar. So for the longitude 72.40 east and latitude 23.02. So in this you can see that this is the position of the sun from east to west, you can see that. And then after it is the motion in the say particular hour. So this is which is showing that the motion of the sun, and this is that these are the season that we are we can say feel on our earth. So this is what you have already know. Now let's move to the next topic, that is latitude and the longitude. So this is the north portion, south portion, and this is the point where we means we are receiving the sun, or we can say annual average position of the sun at the equator. So this is the line which is showing that this is equator. Now zero reflection as angle of the incident and angle of the reflection. So we are getting the straight line from the sun over here. Now let us see if the sun is moving like this. So due to this movement, the rays that we have received at this point will become inclined, and at this point it will become straight again. On the top portion it will become inclined. So due to the motion of the sun, we will get the different means in the irradiation, and then after we'll get the maximum or the average output from the sun due to the motion of the sun and earth. So over here you can see that this is the position where we have placed our solar PV module. So you can see that these are the rate that we are getting from the sun, and this is the reflection that we are getting. So this is what the angle difference from the x and y that we have studied from the air mass. Now you can see that for the zero reflection as the angle of the say incidence, you can see that this is the placement of the sun solar PV panel, and this are the rays that we are getting over here. So this is the angle that we need to keep means वो एंगल हमको रखना है जैसे कि हमारी सोलर पी पैनल हमको मैक्सिमम आउटपुट दे, बिकॉज हमारी पोजीशन कहाँ पे है, हम कहाँ पे है, और मीन्स ऑन दिस अर्थ, एंड अकॉर्डिंग टू आवर पोजीशन वी नीड टू कीप द azimuth angle and the altitude angle of the solar PV panel, so that we will get the maximum output, or we can say tilt angle. So this is what the tilt angle is showing at this point. You can see that हमारी पोजीशन भले यहाँ पे है, but we are getting the straight wave means rays from the sun on the solar PV module. Now this is the solar time versus local time that you are aware with this. So let us see what is the solar time and the local time. So this is 12 p.m. the Indian Standard Time, and we can see that see the sun say overhead say half hour ago. So yes, half hour ago over here you can see that the means before 12 you will get the sun is on the head around 11:30, and over here you can see that the will receive sun overhead after half an hour. So at this point we will get the means the sun position that on our earth on the head after half an hour. So after means at 12:30 we will get the sun at our on our head. So this is what the difference of the places when we have the sun on our head. And at this point you can see that exact 12 p.m. Indian Standard Time will receive the sun which is on our head. Now this is what the say sun dial. Now let us see the total temperature that we have received. So T local plus say longitudinal, or we can say reference, or the longitude that we have means we are on it मतलब जहाँ पे हम अवेलेबल है, मल्टीप्लाई बाय 4. सो दिस इज़ द इक्वेशन विच इज़ अवेलेबल to measure the temperature, or we can say we'll get the solar maximum output from the solar panel. So for Ahmedabad, the longitude is 72.40 east and latitude is 17.02 north, and for India, the reference is 82.30 east and the difference is 9.50. So from that corresponding 9.50 multiplied by 4 minutes, we are having the difference of 39 minutes and 20 second lag. जब हमारे सर पे एग्जैक्ट सन आता है तो हम ऐसा बोलते हैं कि 12 बजे एग्जैक्ट सन सर हमारे सिर पे होता है, बट ऐसा नहीं है. एग्जैक्ट 12 बज के मतलब मीन्स 39 minutes and 20 seconds आफ्टर द 12 PM विल हैव द सन इज़ ऑन आवर अर्थ एग्जैक्टली. सो ये जो है वो बताता है कि हमारे सन की पोजीशन क्या होगी थ्रू आउट द डे. सो हैंस द सोलर say noon in Ahmedabad at 12:39 PM. At that time means solar is exactly on our head. Now this is the earth coordination system. So this is say particular this line which is say showing that particular position of the means placement of the countries, or we can say हम यहाँ से मतलब यूनिवर्सल से ट्रांसफर्स मर्केटर UTM सिस्टम, उससे हम अंदाज़ा लगा सकते हैं कि हमारी पोजीशन एग्जैक्टली क्या है, मतलब जहाँ पे हम खड़े हैं. सो फ्रॉम दैट वी कैन एस्टाब्लिश और वी कैन प्लेस आवर सोलर पैनल. अब यहाँ पे आप देख सकते हो कि कलेक्टर इंक्लिनेशन फ्रॉम द हॉरिजॉन्टल. सो सपोज सन पोजीशन यहाँ पे है और वी आर रिसीविंग द स्ट्रेट लाइन फ्रॉम द सन ऑन दिस पैनल बाय कीपिंग दिस एंगल. सो ये जो एंगल है वो है नून सन एंगल. इट इज़ 90 डिग्री लैटिट्यूड एंड द लैटिट्यूड इज इक्वल टू 50 ओवर हियर. सो फ्रॉम दैट वी विल get the collector inclination from the horizontal. So at 50 degree we will get the maximum, or we can collect the maximum irradiation or light from the sun if we place our solar panel like this. So this is what the azimuth angle that we have already studied. So this is the position of the panel and this is the motion of the sun, and we will get the maximum efficiency by placing means with correct azimuth angle of the solar PV module, and we will get the maximum output from the sun. नाउ यहाँ पे आप देख सकते हो कि हमने एक सोलर PV मॉड्यूल रखा है और ये सोलर मीन्स सन विच इज़ एट दिस पोजीशन. तो यहाँ पे अल्फा इज द सोलर एजिमथ. यहाँ पे आप देख सकते हो सोलर एजिमथ एंगल फ्रॉम द साउथ, एंड गामा एस इज द सोलर एलिवेशन फ्रॉम द हॉरिजॉन्टल. सो आप यहाँ पे देख सकते हो कि सोलर एलिवेशन विच इज़ एलिवेटेड फ्रॉम द अर्थ सरफेस, एंड अल्फा इज द एजिमथ ऑफ से PV generator. Means this is the alpha which is showing that the azimuth angle of the PV module, and beta is the tilt angle of the PV generator. So this is the tilt angle that we need to decide for the better output or maximum output of the solar PV generator. So this will be useful for the placement of the solar PV module for the maximum output from the PV generator, or we can say solar PV module. So this is overall scene that we have studied till yet. So we need to keep this solar PV module at an angle so that we will get the maximum efficiency from the solar PV module. Now these are certain angles that which are showing that the efficiency of the say module. So if it is say means parallel to the surface of the earth, then we'll get the 93%. And you can see that this is the south point at which means if we keep our solar panel if we need to say हमको अगर हमारा सोलर PV जनरेटर इन अहमदाबाद लगाना है गुजरात में, तो हमारा जो पोजीशन मीन्स प्लेसमेंट ऑफ द सोलर PV मॉड्यूल है वो 23 डिग्री साउथ फेसिंग. तो दिस इज़ द फेस ऑफ द साउथ और हमने यहाँ पे रखा है, तो वी आर गेटिंग द मैक्सिमम एफिशिएंसी, और वी कैन से 100%. सो दिस इज this diagram is showing that the placement of the PV module so that we will get the maximum efficiency from the solar PV module. So this is the effect of the module orientation on the energy. Now this is showing that the optimum tilt angle. So as we change the tilt angle, we will get the different say in the efficiency of the solar PV module. So this is the practical output of the solar PV module. If we place our solar PV module at different angle, and afterward we will get the different efficiency of the solar PV module according to the placement of the module. So module power, say actual radiation which is collected by the fixed module, and the green which is showing that the incident power, or we can say solar radiation that would be collected by a collector, say constantly tracking the sun. So yes, solar PV module, in solar PV module we can connect the solar tracker also, so that it will track the sun position, and so that we will get the maximum efficiency from the solar PV module. Now the power on the horizontal, say radiation, or we can say collected by the fixed module. So this graph is showing that the during the day how much is the, say, kilowatt hour per meter square per day that we have received by the different tilt angle. Now the seasonal optimization of the tilt angle. So yes, we can we can do the seasonal optimization also for the for to get the maximum efficiency from the solar PV module. Now these are certain optimization that we can do for the better output of the solar PV module. So over here you can see that this is the position of the solar PV module, and we can change the angle of the solar PV module according to the season. So yes, for annual, say optimum tilt angle is approximately the value of the latitude. So for that we are having the 23 degrees south facing, and tilt angle optimized for the winter from the latitude is plus 15 degree, that we need to optimize for the better output from the solar PV module. And for the summer, from the latitude, that is minus 10 degree. So yes, we need to do this we have to do this modification for the better output of the solar PV module, and which is say applied for the seasonal, or we can say tracking of the PV module, or we can say solar water heater. So yes, we can do this optimization for the maximum efficiency of the solar PV system. Now so let us discuss the incident angle and IM losses. So yes, we can determine the losses using this this triangle. So over here you can see that this is the position, or we can say placement of the solar PV panel, or it is called the hypotenuse of this triangle, and this is the opposite side, and this is the adjacent side, and this are the radiation which means this is the radiation that we are receiving from this side. So you can see that it is the cosine angle of A. This is the angle of A, which is say length of the adjacent side. So this is the side, or we can say position of the solar PV panel. And if you draw a line from the solar PV panel over here, so this will be the adjacent side, or we can say length of the solar PV module, and this is what the length of the hypotenuse, and it will show the angle cosine, and that will from that cosine angle we can find the incident angle, or we can say the IM losses from the of the of particular power solar PV module. Now this is the say magnetic declination. Magnetic declination is basically is shown in this map. You can see that this is the universal magnetic declination, which is this is taken in the 2010. So basically magnetic declination is the say positive declination is positive when the magnetic north is east of the true north. So yes, you can see that this is the north and south, and suppose we draw a straight line from this side, so this is what the declination which is showing over here. So this is the NG, or we can say this is not graphical sorry, geographical position, and this is the say the magnetic north. So this is the angle which is created on the earth from the say NG to NM is called the declination, or magnetic declination angle. So magnetic declination basically is the angle between magnetic north and the true north. So from this diagram you can see that the position of this in this previous case, you can see that this is the position of our country, and it is how much angle magnetically declined that we need to find out for the better output of the solar PV module. Now the points that you means understand for the solar energy. So ask yourself that can plant can survive without sun's radiation, or we can say solar energy. And the second question that you need to ask to yourself, that is when my solar PV system generates the when my solar PV system generate the more power during winter, summer and monsoon. Can you explain? And the third question that you need to ask to yourself, that is when will my PV system generates more power during morning, evening or noon? Can you explain? So this is what I am done in this presentation. So thank you very much, student, to listening me. And if you have any query or doubt related to this topic, you can meet me in the electrical department of SSIT Gandhinagar. So thank you very much, student. Thank you all. Jai Swaminarayan.